Tidak aktif pula dia ni.
So, good morning class.
Morning.
So, today we will learn about hydrogen bond. So, do you guys know what is hydrogen bond?
Huh? Hydrogen bond? What is that? I've never heard about that.
Well, hydrogen bond is defined as a weak bond between two molecules, this molecule and this molecule, due to the electrostatic attraction between proton in a molecule and electronegative atom in the other. So, as like I draw this, so this is the structural form of hydrogen bond between water. So this is the hydrogen bond, and as well as this one.
Miss, so that means water is bonded covalently with hydrogen bond.
Yes, exactly. And thanks to their polarity, water and water molecules happily attract to each other. So Daniel, can you relate hydrogen bond with the chapter that we have done before?
Yes, there is a weak attraction between the positively charged of oxygen and the negatively atom, which is oxygen.
That's right. So in today's topic, I will focus more on application and its history. So the hydrogen bond was first identified in year of 1776 by he's a British scientist named Henry Cavendish. And he discovered the hydrogen bond after he evolved a hydrogen bond in an experiment of between a reactive metal, which is zinc, and hydrochloric acid.
The hydrogen was first identified in 1776 as a distinct element by British chemist Henry Cavendish after he evolved hydrogen gas by reacting zinc metal with hydrochloric acid. In a demonstration to the Royal Society of London, Cavendish applied a spark to hydrogen gas yielding water. This discovery led to his later finding that water is made of hydrogen and oxygen. He discovered hydrogen, calling it phlogiston or inflammable air, and reported that it produced water when reacted with oxygen, establishing water as a compound, not an element. In 1778, French chemist Antoine Lavoisier gave hydrogen its name, which was derived from the Greek words hydro and gens, meaning water and born of. He later reproduced Cavendish's experiment and gave hydrogen its name. Water's composition was discovered by Cavendish around 1781. This composition was confirmed in 1800 when the amounts of hydrogen and oxygen produced by the electrolysis of water were measured by Johann Ritter. Hydrogen bond in water was first suggested by Wendell Latimer and Worth Rothbush. In 1920, Latimer and Rothbush, working on structure and properties of water with Gilbert and Lewis at University of California, Berkeley. At the time, Wendell Latimer was a lecturer in Gilbert and Lewis Chemistry Department at University of California, and Rothbush was a postdoctoral fellow. Latimer and Rothbush do not use the term hydrogen bond or hydrogen bonding in their paper. The closest they came was to describe it as the hydrogen nucleus held between two octets constitutes a weak bond. Their paper was completely ignored for 10 years. In the Latimer-Rothbush paper, they introduced the concept of hydrogen bonding to explain certain phenomena. which were already well known, such as anomalous boiling point of water, vapor phase, density of hydrogen fluoride, and vapor density curves. During the 1920s, the number of chemists adopting their concept was increasing and became greater during the 1930s. By 1973, the concept was so widely accepted, and the term hydrogen bond had also by far the most common name.
Application of hydrogen bond. Hydrogen bonds are commonly found in water molecules, protein structure, antibodies in medical field, and also applied in industry, which is found in the fertilizer. A water molecule consists of two hydrogen atoms bonded to an oxygen atom, and its overall structure is bent. This is because the oxygen atom, in addition to forming bonds with the hydrogen atoms, also carries two pairs of unshared electrons. These attractions are examples of hydrogen bonds, with interaction that form between a hydrogen with a partial positive charge and a more electronegative atom such as oxygen. Hydrogen bond for formation in protein. Hydrogen bond in protein allows this protein to bend, fold, and fit into various shapes as necessary, which determine the protein's activity. There is application of hydrogen bond in DNA. Hydrogen bond holds complementary strands of DNA together that occur between complementary nucleotide base pairs. Two hydrogen bonds occur between the adenosine and the thymine base pairs, and between the cytosine and the guanine. Internal and external hydrogen bonds stabilize the DNA molecule. The hydrogen bond in antibodies. Antibodies are folded protein structure that precisely target and fit a specific agent. Antibody and the antigen will lock with each other through a series of interactions, including hydrogen bonds. Hydrogen bond in industries. Hydrogen bonds are used in the fertilizers and paint industries. It is also used in the food and chemical industries. Food industries use the element to make hydrogenated vegetable oils such as margarine and butter. In the procedure, vegetable oils will combine with hydrogen. By using nickel as catalyst, solid fat substances are produced. In petrochemical industry, hydrogen is required for crude oil refinements.
So that's all about history and its application of hydrogen bond. So do you guys understand?
Yes.
Did you get it right?
Yes. Now we know.
Okay, so class is dismissed.
Okay.
Okay.